Here's 5 types of data science projects that I recommend you having in your data science portfolio. Hey everyone, welcome to the channel. My name is Leon. I'm a data scientist based in the UK, and doing projects is a very important part of doing data science. And that's because data science is a very broad and complex field, and doing projects is just an easy way for you to show your technical skills and your soft skills like teamwork and communication skills. And it's just a good way to show that you know how to extract actionable insight out of data in various different ways. So here are the timestamps, and these are the 5 types of projects that I recommend having in your data science portfolio. Let's get right into it. Almost every data scientist job that I've seen requires you to have some knowledge of creating data visualizations, especially dashboards. Creating good dashboards means you can tell a good story, and it allows people to interact with the data by themselves. And that's why data visualization tools like Power BI and Tableau are extremely useful to know. Now, you could use tools like R or Python to create data visualizations, but that would require a lot of coding. And to be honest, most people don't care that you can create fancy visualizations with code. Most people just want something that's practical and reliable that they can use every day, and that's why most companies already have tools like Power BI or Tableau in place. I personally would recommend using something like Tableau Public, which is the free version of Tableau. They have a website where you can publish your dashboards to, and you can use that as an online portfolio. There's also a free version of Power BI, and I've had experience using both tools. Personally, I prefer Tableau, but that's just me. Either one is good, they're both very popular. If you want to take it a step further, Power BI and Tableau offer certifications, but in my opinion, having a portfolio is the priority, and then you can worry about the certifications later. Exploratory data analysis, or EDA, is about finding insights from data, and it forms the foundation of almost every data science project. EDA requires cleaning and manipulating the data, identifying and dealing with anomalies, statistical analysis to understand the data more, feature engineering for training machine learning models, and data visualization so that you can actually see what the data looks like. In my opinion, EDA should be the first type of project that you do because you need it for modeling, and it helps answer questions that drive business decisions. I would recommend using data that's a little bit messy, or you can even scrape the data yourself, because that makes it a little bit more realistic and interesting when you show your results. If you've done even a little bit of statistics, you'll know that regression is one of the first things that you'll learn. And there's a good reason for this, because regression is used to forecast a continuous variable. A couple of examples of this would be like trying to predict the price of Bitcoin next year, or trying to predict the height of a child in the next 10 years. These are all problems that have a continuous outcome. In my opinion, you should start with something simple like linear regression, because everybody uses linear regression at some point, and then you can use something a little bit more difficult like random forests. If you don't know what that is, I have a video up here that you can check out as well, and then you can start doing the cool stuff like time series forecasting with neural networks as an example. Also, as a side note, make sure you think carefully about how you evaluate your models, because that's going to determine how your model performs. Classification is all about predicting categorical outcomes. This is called a supervised machine learning technique because it requires labeled data, which is data that has been marked with labels or classes. If that's unclear, then imagine we have a data set of customers. Their gender or nationality could be their classes, because each customer could fall into one of these categories. In a classification problem, you're trying to build a model that can predict these classes. I'd say this type of problem is probably the most popular for data scientists. Just like regression models, model evaluation is important here as well. Let's say you're trying to predict fraud, then you would want to look at other evaluation metrics like precision and recall, rather than just look at accuracy by itself. Also, some classification models give you a probability when predicting a class, and that helps you explain your predictions, which is extremely important for any business. I personally would recommend an algorithm like XGBoost, or if you want something simpler, you can start with logistic regression, and then later you can do cool stuff like object detection, object tracking, like the project that I did up here, which is very useful to impress employers with because you can actually see the algorithm in action. Clustering is about grouping similar data together. More specifically, it's an unsupervised machine learning technique because it doesn't require labeled data. Clustering can be used in exploratory data analysis or feature engineering to generate the features for training machine learning models. In exploratory data analysis, clustering helps us understand the data more by letting us see the possible relationships between the data points. Once you know the groups in the data, then you can start applying labels to each group, which help generate the features for machine learning models. As an example, we might want to group customers based on their spending or the products that they've purchased. This might give us some insight into customer behavior. I might end up having two groups, so a high value customer group and a low value customer group, and then I can use these as features to train a machine learning model to predict something else, or I can train a machine learning model that predicts whether a customer is a high value one or a low value one. It essentially becomes a classification problem. Basically, clustering is quite flexible in how you want to use it. You can do a project dedicated to just clustering, or you can do another type of project where you incorporate clustering as part of that project. Now that you know which type of projects to do, you might also want to know how to structure your data science projects. So I have a video on that up here, which you can check out. You can also follow me on Instagram, and if you like this video, please like and subscribe, turn on the notification bell, and I'll see you in the next one.